Hi students, in this video I'll be going through the 2023 A Math paper 2 question 7 part B. Alright, so this is a question regarding kinematics. Okay, so let's read the question. So a particle traveling in a straight line has velocity v at time t seconds. Okay, so t is greater or equal to 0. Okay, the velocity is given by the equation v equals to phi sine 0.2t plus c, where c is a positive constant. Okay, so one key thing to take note, c is a positive constant. Find the smallest value of c in order that the particle will never change its direction. So the particle never changes its direction. Okay, so in kinematics, do you recall how do we indicate direction? Or how is the direction determined? Okay, so the direction is determined by the sign of the velocity. So if the velocity has a negative sign, right, the velocity is negative, okay, it means that the particle, in this case, right, okay, usually we let negative direction be the left side. So if the velocity is negative, means the particle is traveling to the left. If the velocity is positive, that means the particle is traveling to the right. Then of course, if the velocity is 0, that means the particle is at rest. Okay. Okay, so over here, how do we know whether okay, to put this v to be always positive or always negative? Okay, so for this we need to observe what is happening at time equals 0. So when you sub t equals to 0 inside here, you will have sine 0. Okay, sine 0 is going to be 0. So 5 times sine 0.2 t is 0 will become 0. Then we will just have v equals to c. But remember, c is a positive constant. It shows that at the start, the particle is moving to the right side. And since it never changes its direction, means the particle always moves to the right side. Okay, so what we can write now is that if the particle never changes direction. Okay, so for this particular case, this question, right, because c is a positive constant, the velocity is always greater or equal to 0 for all t. Okay, the velocity can be 0, it can actually be at rest, okay, and then continue, maybe later on continue moving in the positive direction. Okay, okay, so the inequality that we can form is phi sine 0.2t plus c, it will be greater or equal to 0. So we need to find the smallest value of c that will satisfy this inequality all the time. Okay, not some of the time. Okay, we need to find the value of smallest value of c that will make this inequality valid all the time. Okay, so how do we solve an inequality like this? Is we always observe this sine 0.2t term. Okay, the trigonometric term. Okay, so do you recall now sine 0.2t? What is the smallest possible value you can get out from this? That means when you put in different values of t, right, what is the smallest possible value? Okay, so if you recall, the smallest possible value will be -1. Okay, because this is actually a sine function with amplitude 1, and the biggest will be 1. Okay, so I've actually drawn out on that small, so we can actually go over there and take a look. So you can see this is sine 0.2t. The biggest value is 1. Okay, the smallest value is -1. All right. Okay, so sine 0.2t is greater or equals -1, but less than 1. So there's a 5 in front. I'll just multiply everything by 5. So we will get this. Okay, then we have a plus c behind. So we have -5 plus c and 5 plus c. Okay, so over here, this is the smallest possible value, okay, of this whole expression. This is the largest possible value. Okay, so in order for this inequality to be satisfied all the time, do we put the smallest value greater or equal to 0? Okay, do we put this one inside here, or do we put this one inside here? Right, so if you think carefully, we should be putting the smallest value to be greater or equal to 0, okay, instead of the largest value. Because if we put the largest value to be greater or equal to 0, and then we find the c, okay, then we use that to find the c. If the largest value is greater or equal to 0, it doesn't mean the smallest value is greater or equal to 0. Okay, so I repeat what I just said. If we put the largest value inside, okay, we put the largest value inside, okay, if the largest value satisfies the inequality, it doesn't mean the smallest value satisfies the inequality. Because the largest value is greater or equal to 0, the smallest value could still be smaller than 0, okay? Okay, but if the smallest value satisfies, then the largest value should also satisfy, right? Okay, so in this case, okay, I hope you understand what I just explained. Okay, so do think about it, okay? Okay, so the smallest value greater or equal to 0. Okay, so you bring the negative 5 over, c will be greater or equals to 5. Okay, hence the smallest c will be equals to 5. Okay, so I can actually verify this using decimals. So that we say that the smallest c to satisfy it, right, should be at minimum 5, okay, 5, right? Okay, so let's go back to decimals. Okay, so I add the 5 in front. Okay, then the amplitude becomes 5. Okay, so the plus c, you'll see what happens if c, we don't put 5. Okay, we just put maybe 4. See, if we put 4, there's some part of the velocity, right? Okay, so now y is the, okay, we can actually change it to v lah, okay? Okay, some parts of the velocity, right, okay, is negative. Okay, that means the particle change direction here. Okay, so it must be at least 5. Okay, so 5 is always positive. At this point is 0, that means the particle stop for a while. Okay, then continue to move in the positive direction, right? Okay, so let's take a look at the second part of the question. Okay, so in the case where c equals to 8, find the total distance traveled by the particle in the third second of its motion. Okay, so if c is equals to 8, then the velocity becomes 5 sine 0.2 t plus 8, right? Okay, so now we want to find the distance traveled. So in the third second of its motion. So in order to do that, we need to find the expression for the displacement of the particle, right? So to get displacement, we will integrate velocity. Okay, so we will integrate this with respect to time. Okay, so we integrate sine 0 sine. Okay, you will get negative cosine, right? So you have 5 negative cosine 0.2 t. Okay, then we'll use the chain rule, differentiate 0.2 t, you will get 0.2, and then you will divide below. Okay, so divide by 0.2. Okay, when you differentiate 8, you get 8t. Okay, because this is an indefinite integral, so we add a constant behind. Okay, so in other words, the displacement will be 5 divided by 0.2 is 25. Negative 25 plus 8t plus c1, right? Okay, so the distance traveled by the third second. Okay, so do you recall third second is between which second to which second? Okay, so 0 to 1 will be the first second. Okay, then 1 to 2 will be the second second. So third second will be 2 to 3. Okay. Okay, so be careful, it's not 3 to 4, it's 2 to 3. Okay, so let's find the distance. Okay, you may be thinking there's a C1 here. So if I put the time 2, right, I will have a C1. Okay, but later on you will see the C1 will cancel off by itself. Okay, so let's try. So when t equals to 2, okay, okay, then the displacement. Okay, the displacement means where is the position of the particle at that point in time. Okay, negative 25 cosine 0.2 times 2, right? Okay, so then plus 8 times 2 plus c1. Okay, so if you're going to compute this whole thing, cosine 0.4 then times negative 25 plus 8 times 2, 16, right? Okay, then you will get this plus c1. Okay, okay, so we'll just leave the c1 there for a while. Okay, then from here we will have when t is equals to 3, so s equals to minus 25 cosine 0.2 times 3 plus 8 times 3 plus c1. Okay, so now you will get 3.3666 plus c1. Okay, so this is the position. Okay, this is the position at time t equals to 2. This is the position of the particle at time t equals to 3. So to find the distance traveled between the distance moved by the particle between those two timings, you will just find the difference between these two distances, okay? So the total distance traveled we will just take 3.3666 plus C1 minus 5 plus C1. Okay, so C1, you see the C1 will cancel itself away. Okay, minus become plus, right? See, the C1 will subtract itself away. So the answer will just be 3.3666 plus 7.0265. Okay, so you should get this one. Then round to 363, you get this. Right? Okay, so this will be the solution for question 7B of the MEF paper 2, 2023 paper 2. Okay, so it's not too difficult of a question. Okay, so of course the part A, the explanation seems a bit complicated, but I hope you can take time to try to understand it. Right?